Welcome to the next session, that is operators. So let's start with it. Yeah, the operators. The operators are as follows: arithmetic operators, assignment operators, comparison operator, logical operator, identity operators, membership operators, bitwise operators. So, like other programming languages, Python also have different operators to deal with different operations. That the first one is arithmetic operators. So arithmetic operators basically which deals with the numeric values, and we can perform the common or the normal or general mathematical operations, that is addition, and plus symbol is used for that, subtraction, minus, multiplication, asterisk, and division, uh, slash, and percentage is for modulus, which then exponentiation, which works like a power of x comma y, uh, and floor division, which divides and provides the quotient. So let's see the thing for it. Okay, let me use the, okay, let me cancel it. Yeah, let me use this, show it in the console. Yeah. X I'm providing the value as 5, and y I'm providing the value as 4. Already we have seen this, but when I'm dealing with the operators, showing the result is appropriate. So x for the multiplication x star y, definitely the answer is 20, and x divided by y, where it provides a floating point value, and x modulus y. Okay, because that is 5 divided by 4, 1. So 1, then exponentiation, that is C, that is x to the power of 5, sorry, x to the power of y, that is nothing but 5 to the power of 4. So the answer is 625, and x floor division y, so that is 1. So 5 divided by 4. So the thing is like the it like we divide it, and whatever is the value, so that is given as a result. Okay, the next operator is assignment operator. Assignment operator here, equal is the assignment operator which we use, and x is equal to 5. It means the value 5 is assigned to x. X plus is equal to 3. It means x is equal to x plus 3. So that is one of the, these are the assignment operator. X minus is equal to 3 means x is equal to x minus 3. X star is equal to 3 means x is equal to x star 3. X divided by is equal to 3 means x is equal to x divided by 3. Then x percentage is equal to 3. X modulus is equal to 3 means x is equal to x modulus 3. X floor division is equal to 3 means x is equal to x floor division 3. X exponentiation is equal to 3 means x is equal to x exponentiation 3. X and is equal to 3 means X and 3. X or is equal to 3 means X is equal to X or 3. So these are the assignment operators. So if the same thing, X, if see the first example, if we see in the value 4 is assigned to X, X plus is equal to 3. It means X is equal to X plus 3. The value is 4, 4 plus 3. So now the value of X becomes 7. So that's the thing here. So in that way we can work with all the operators, that is X minus is equal to 3. So the value becomes 4. Then X star is equal to 3. X is equal to, the value of X becomes 12. X divided by is equal to 3. So the value becomes 4.0. X modulus is equal to 3. So that is 1.0. Then again X exponentiation 3. Okay. The value is 1.0 because 1 to the power of anything is 1 only. Then X and 3, X or 3, that will deal it in the later part when we are dealing with those operators, and or and bitwise operators or logical operators. So that is about assignment operators. So the next thing is comparison operators. So basically for the comparison, we use these operators, and those are equal, where we use the symbol double equals, and for all these operation the result will be in terms of Boolean. It checks whether value of X, whether it is equal to Y. If it is true, it returns the value as true, else it as false. If it is not equal to Y, true. If it is not, false. If greater than Y, true. If X is less than Y, true. Greater than or equal to whatever. It depends on the value of X and Y. Depending on that, it compares and it provides the result. So let's see the example. Let's see the example. Yeah, we were talking about the assignment, comparison operator. I'm just assigning the value for X and Y because I have opened a new console. If X is equal to Y, no, it is not equal, so it is false. The answer is correct. X is not equal to Y. Yeah, it is true. X is greater than Y. No, false. X is less than Y. True. X is greater than or equal to Y. No, false. X is less than or equal to Y. Yeah, true. So this is how it results. Either we can directly produce the result, or we can assign it to any variable, that value, and we can produce the result with the help of it. So in that way we can make use of the comparison operators. Okay. The next operator is logical operators. So logical operators are and or not. So what happens here? If both the results are true, the result will be true. If X should be less than 5 and X should be less than 10. If both the result are, if after comparing, if both the results are true, then the result is true, else it is false. if any one of the value is false, or if any one of the result is false, the final result will be false. It returns if one of the statement is true. If x is less than y, or if x is less than 4, if any one of the result is true, the result is true. And it reverses the result. If at all, if for example, if the previous example, if we take, if the result is true, it reverses the result. It means it becomes false. So let's see the okay. Okay, as you can see here, every time I'm assigning, because I'm using it in the console, so it's okay. Okay, let me change the value of y. Okay, so and if x is less than 5 and x is less than 10, yes, x is not less than 5, x is equal to 5, right? So since the first expression's result is false, the final result is false. Okay, let me reframe it. So the answer must be true. Oh, syntactical error. I have a mistake here. Let me correct it. Yeah. So now let's deal with OR operator. X is greater than 6 and or x is less than 6. So what should be the answer? True, because the first expression doesn't hold the result as true, but whereas the second expression holds the result as true. So definitely if any one of the values or the result is true, the final result will be true. So let's apply not to this result. Not false, because see, the final result is true, so complement of it becomes false. So this is how we can make use of logical operator. Okay, the next operator is identity operators. So basically these operators refers to the objects. If it means, see, you can see the description here, returns true if both variables are the same object. I'll show an example to with this, you'll understand it in detail. And x is not, again, if it results true, returns true if both variables are not the same object, the complement of it. So if we see the example for it, you'll understand in detail. What I'll do is I'll create a list for this, tuple for this a comma b. Okay, let me create one more tuple, that is okay, same thing. Let y also, let it hold the same value. Okay, so now x is having ab and y is a tuple. X is a tuple which holds the elements a and b. Y is a tuple which holds the value as A and B. So now the question is whether X is Y. So what do you think? Whether X is Y? What should be the answer? What should be the answer? It should be false. Why? Because X is a different object, Y is a different object. It is referring when X is referring, it has same elements, but here we are not at all talking about the elements. Rather, we are talking about the object. The reference of that object is different. So now what I'll do is I create like this. Now whether Z is X, true, yes, because I have assigned directly to Z. So both are same. Both are same now. So hope it is clear. This is called identity operator. So here, if it is referring to the same object, then only it returns true. Here what is happening is X and Z, they both are referring to the same object. I have created an object X and I'm assigning it to Z, so both are referring to the same object. But when it comes to Y is a different object. Rather, if I do like this now, Y is equal to X if I do, and then if I write the statement as Y is X, it returns true. If I write the next statement, Y is not X, now it returns false, because the complement of this result should be false, right? So this is called identity operators. The next is membership operator. Membership operator. So whereas it returns true if a sequence with a specified value, if it is present in that object. If it is not, then it returns false. And a complement of it is not in. So let's see again the example for it. Okay. What I'll do is again one more list or tuple I'll create. X is equal to, okay, let me have a same kind of values in it. X. Now I don't require one more tuple. Rather I'll use like this now. So I have to find whether the given element, whether it is present in X. If so, it returns the value as true, else it returns the value as false. So A in X, of course, true. Let me check with the value which is not present in the X. In X, false. So let me complement that the previous statement. So that is C not in X, true, right? So A not in X, false, because A is present in X, C is not present in X, right? So this is how we can make use of membership operator in Python. So the comparatively with the other languages, almost all the operators are same except this membership and identity operators. So the next operator is bitwise operator. So bitwise operator, uh, this is in general it is common everywhere, where the comparison will be done in terms of bits, in terms of zeros and ones. So let's start the operation. The first operator is AND operator. So how it operates? So the description given is sets each bit to 1 if both the bits are 1. Sorry. See, you can see the description here. Sets each bit to 1 if both bits are 1. It means, you can see the example here. For example, if you consider the first value as 12, for example, x is equal to 12 and y is equal to 25. And we are applying the operator as and x and y. So what happens? And it is converted in terms of binary, and 25 is converted in terms of binary. And the AND operation is applied. So what the statement says, sets each bit to 1 if both bits are 1. Bitwise it is compared. If both the bits are 1, then the result is 1. So you can see here 0 and 1. No, both the bits should be 1 to result as 1. So 0 and 1 is 0. 0 and 0 is 0. 1 and 0 is 0. 1 and 1 is 1 because both the bits are 1. Then the result is 1. 0 and 1 is 0. 0, 0, 0, 0, 0, 0, 0, 0, 0. So this is how it results in bitwise AND operator. Hope it is clear. For the sake of showing, let's deal with the same example. X is equal to 12, y is equal to 25. Let's apply x and y, and the answer should be 8. Yes, yes we have. Okay, that is about bitwise AND operator. Bitwise OR operator, when we apply OR operation with the x and y, what happens? Sets each bit to 1 if one of two bits is 1. Any of the bit, if it is 1, the result is 1. In the earlier case, both the bit should be 1 to get the result as 1. But when it comes to OR, any one of the bits, if it is 1, the result is 1. So we can see the example here. So the OR is applied here. 0, 1, 1. Because one of the bit is 1. 0, 0, 0. 1, 0, 1. 1, 1, 1. Yeah. If any or if both, definitely the result is 1. 0, 1, 1. 0, 0, 0, 0, 0, 0, 0, 0, 0. So when we apply x or y, the result should be 29. Yeah, we got the result. XOR. What happens when we apply XOR operation to x and y is, it sets each bit to 1 if only one of two bits is 1. It sets if only one of two bits is 1. So we can see here XOR. In the previous case, in the OR, what used to happen is, if any one of the bit, if it is 1, the result is 1. And if both the bits are 1, then also the result is 1. But when it comes to XOR, how it operates is, for it, any one of the bit should be 1. So 0, 1, 1, 0, 0, 0, 1, 0, 1. 1, 1 is 0 because it is expecting any of the bits should be 1, not both the bits should be 1. So here the difference, you can find the difference between OR and XOR is, in the OR it is 1, 1, it was 1, but in the XOR 1, 1 is 0, 0, 1, 1, and again 0, 0, 0, 0, 0, 0, 0, 0, 0. So this is how it operates in XOR. X or XOR. Okay, oh sorry, X. Yeah, 20. And the next thing is NOT. So not is definitely inverts all the bits. If it is 0, it will be converted as 1. If it is 1, it will be converted as 0. So 35. So that is 1 is 0, 1 is 0, 0 is 1, 0 is 1, 0 is 1, 1 is 0, 0 is 1, 0 is 1. Okay. Okay, let me give the same value. Yeah, let me, okay, find out the complement of x. Oh, where is it? Yeah, it's here. Yeah, 36. Why? What happened? Complement. X is 35. Okay, I'll do one thing. Let me assign it to some other variable. Okay, minus 36. Okay. Okay. Let's see the next operation, that is left shift and right shift. In the left shift, what happens is it shifts the left by pushing 0 in from the right and left. Let the leftmost bits fall off, and right shift, it pushes to the right, and the leftmost bit will be the rightmost bits will fall off. So we can see the example here, right shift in binary, 212 has been converted to binary, 212 right shift 2. So what happens is here, this rightmost 2 bits will fall off. So in the LSP, 2 zeros has been added. So these 2 zeros will fall off. So 1, 0, 1, 0, 1, 1, and the spaces will be filled with zeros. Since I have mentioned 2, if you mention 7, what happens? So again, 7, 1, 2, 3, 4, 5, 6, 7, all these things will fall off, and it starts with 1, and all other positions will be filled with zeros. If you apply 8, everything will go and it starts from 0. If you give 0, nothing shifts, no shift. Okay, let's do this. Sorry, I have not to apply. Okay, I'll do one thing. I think we cannot see because okay, let me let me take the number itself. Okay, it's providing its value, what is happening later. Since I cannot since it's not been converted to decimal, it might be okay. Let me show it as 8. Okay, 0, as we have seen here. See, you can see here 212, right shift 0, no shift. So 212 is the answer. So okay, this is about right shift. Left shift, the same 212 example. So here you can see left shift 1. So here what is happening? Left dot, see, this has come to the left, this here, this 1 is here, 0 is here, 1 is here, 0 is here, 1 is here. What is happening is 1 0 has been added. The left left shift, okay, it remains same, and the 0 has been added to the rightmost position. So 212, 0, left shift 0, nothing happens. shifts by nothing. 4. 4 you can see. 4 zeros has been added here. So let's see that in the example. So that is 212 again. Okay, 212 12 rows. So then it becomes 424. So 212 left shift 4 if I give nothing, sorry, 212 left shift 0 if I give nothing happens, it is 212. Okay, 212 left shift 4. So in the binary some number is given, yeah, 3392, yeah, the same result we have got. So this is how the bitwise operator works. So as we can see this yeah, if I do a quick revision for it, the in this session we have seen the operators, where it starts with the arithmetic operator, that is addition, subtraction, multiplication, division, modulus, exponentiation, and float division, and assignment operators, and the comparison operator which results in boolean value, and logical operators. Okay, we have done it everything, all the exercises in fact. And identity operator, which majorly it operates on object, not only major, not majorly, or it completely operates on objects. And the membership operator, it checks whether the particular element is present in that object or not. And bitwise operators, and or XOR not, left shift and right shift, and each one we have seen with the example. That's all for this video.